morning everybody. Here in this video I will show you how to apply Lhopital rule, but this is not the main cases of the Lhopital, but here I think the sub-main cases of Lhopital, this form 0 to power 0. Okay, for example, evaluate limb. Okay, sorry, here limb limb sine x to power x, sine x to power x, as x approaches 0 from right. The first step here to solve this equation, be careful about this. You should just substitute directly x by 0. This is equal, we can substitute now sine 0 to power 0. This is equal 0 to power 0. Okay, this is form. Okay, now I cannot apply Lhopital rule if we have in this case, but to apply Lhopital rule you should distinguish between the cases that we can apply Lhopital rule in just in two cases, 0 over 0 or infinity over infinity. But here 0 to power 0, this is not a case of Lhopital. What we can do, maybe here I think maybe we assume here y is equal sine x to power x. Okay, now lim y is equal x, sorry, just wait. Okay, we will continue inshallah. I think maybe some problem happened here in this computer. Let's see what happened. It's maybe the problem here. Okay, now sorry for this interpreting for the maybe happened breakdown of the computer. No problem, we will continue. Lim y is equal lim sine x to power x. We can here lim y is equal x lim sine x. Okay, here if okay, we can take now, this is the lim as x approaches to 0 from right, this is equal lim for this. Here we can just this is to leave more space. Yes, lim x lim sine x. Okay, as x approaches to 0 from right, if substitute here, I think equal Okay, now I can write this lim lim sine x over 1 over x. The same, just this is as x approaches 0 from right. If I substitute here, this is equal ln sine 0, okay, 1 over 0. This is equal infinity over infinity. This is Lhopital. This is Lhopital. I can apply here. Here we can apply Lhopital. Lhopital's role. Yeah. Okay. Now this is derivative. This is lim. Okay. Derivative. This is derivative ln sine x. I think cosine x over sine x. Derivative 1 over x. This is equal derivative of 1 0 times x 0 minus derivative of x 1 minus 1 over x squared. This is quotient rule. Okay, as x approaches 0 from right, this is the, we can see here, this is cotan x over negative x minus 2. Okay, if substituted here x by 0, I think this is equal cosine 1 over 0. This is 1 over 0. This is equal the same infinity over, I think, over infinity. Okay. But before apply Lhopital again, we can do here a simplification. Okay, be careful about this step. Here we can write this is equal lim cosine x over sine x times, I think, x squared minus 1. Here, as x approaches 0 from right, we can write here lim. This is x squared. I can write x over sine x times x cosine sine x over minus 1. Okay, as x approaches 0 from okay, from right. Okay, I think here this is equal lim x over sine x as x approaches 0 from right times lim minus x cosine x as x approaches 0 from right. We can continue here. This is equal 1. times minus 0 times cosine 0. This is equal 1 times 0. This is equal 0. This is what? This is ln y. Ln y is equal 0. We can write y is equal e to power 0. This is equal 1. 1. Yes. We can say ln finally sine x to power x as x approaches 0 from right is equal 1. This is the final answer. The question isn't easy, but I think if you fluid the steps step by step, I think you should understand. Thank you for watching video. We will see you inshallah in the next video.